I'm glad you asked the question about why rocks are different colors, because sometimes it's impurities in the rock that causes that. So, for example, you're probably very familiar with quartz. Quartz is, it's like the second most common mineral or rock in the crust of the earth. The other one being this one, feldspar. This is probably number one. The quartz is probably number two. The quartz comes in different colors. For example, it can come in pink. This is rose quartz, and it's caused by an impurity, a metal that's in it. And they think it's either gold or titanium, some kind of really cool metal that causes this beautiful rosy quartz color. Another one, an example, is going to be amethyst. Here's a beautiful crystal of amethyst. Look how pretty that is. These crystals all have 6 sides. They're hexagonal, and that's because quartz and amethyst are in the same family. And the reason why the amethyst is purple instead of white is because of an impurity, in this case, probably iron. So there are a lot of different things that can cause that. Now, let's talk about identifying our minerals and how we're going to do that. So one of the ways that we can identify a mineral is by a scratch test. Mr. Broughton just alluded to that just a second ago. So some minerals are one color when they're in their crystal form. This is iron pyrite. Miss Ramirez showed you that. This is what the crystal of iron pyrite looks like. It's called a pyritahedron. Isn't that beautiful? It looks like a rose. Well, I have a piece of iron pyrite that's all sparkly and gold, the kind that fooled the miners. I'm going to scratch it on this scratch plate. And when I do this, when it's powdered, it's not going to be sparkly and gold. It's going to be a dull charcoal gray. Let me show that to you. Can you see that? It looks like a pencil mark, doesn't it? So when you use a scratch test on a on a piece of iron pyrite, you get this charcoal gray mark instead of a sparkly gold one. So that's one way we can identify minerals, is by using a scratch plate like that. All this is an unglazed piece of porcelain or ceramic tile. All right, let's look at another one. Let's look at crystal shapes. Since we talked about crystal shapes a minute ago when we were talking about the quartz and the amethyst. Amethyst and quartz, because amethyst is part of the quartz family, have a hexagonal crystal. It's the way it's normally going to form. This is fluorite. We've seen fluorite a lot, and it comes in every color. Fluorite comes in every color according to the impurities that are in it that make it either green or blue, or in this case, purple. Look at that thing. Isn't it gorgeous? It formed an octahedron. I didn't cut it like that. That's the way it formed. Isn't that beautiful? That's a beautiful crystal. All right, well, we're going to put the, let's see, I've got another crystal here. Oh, this is halite. Halite forms a cubic crystal, and it's got cubic cleavage. So every time you break it, it's going to form a cube. And that's because of the crystalline structure of halite. Another name for halite is salt. So you have a lot of halite at your house. You can take a little hand lens. I think I've got one right here. And you can look at it with this. But if you look at the salt from the salt cellar or the salt shaker at your house, guess what? It's all going to be little cubes like this. How about that? Okay, another one. Calcite. Calcite is in the shape of a rhombus, and that's how it forms, and it's got rhombal cleavage. So when you break it, it's always going to break into a rhombus. Another piece down here. There it is right here. Look at that. Can you see that rhombus? Hold it up against my shirt. You can see that rhombus right there, just like this rhombus. And guess what? If it gets smaller, guess what it's going to form? A rhombus. So that's a neat thing about calcite. Calcite's very useful. We have a lot of calcite in Texas. All right, let's see. What else do we have here? While we're still talking about crystals, I'm going to show you some granite. Mr. Broughton had a little piece of granite that he was massing for you. Well, here's a bigger piece. This is called basement rock. It's granite. It's from Oklahoma, and it's part of our continental crust. It's very interesting. And you can see all the different crystals in there. Crystals take a very long time to form. And so the bigger the crystals, the longer it had to form. So these crystals are not particularly big, but they're larger. You can see them with the naked eye. You don't have to use a hand lens to see these. The pink ones are this Orthoclase Feldspar right here. This is the most common mineral or rock in the earth. The black one's something called hornblende. The sparkly white one are quartz crystals. We've already talked about that. But the ones that look like glitter, it's something called mica. Mica is very neat because it's got cleavage also. It's got basal cleavage. Look at that. Isn't that beautiful? Almost looks like a big fish scale or something. This is biotite mica. And you can remember that because biotite and black both start with the same letter, B. This is Muscovite mica. And this mica is silver. And that's what makes that glittery look in the granite when you see it. These little crystals of mica. And every time you break it, it's going to break off in these little flakes. Just like a little piece of biotite I had. Look how thin that is. Can you see that? That's how it breaks. It's called basal cleavage. Very nice. Okay, and let's talk real quick about hardness. Okay, now there was a real famous scientist. His name was M-O-H. And he discovered that minerals have very specific hardnesses. And the softest mineral we have is one called talc. And this is what it looks like. Can you see how beautiful it is? It reflects light like mother of pearl. And so we say it's got a pearly luster, but it's real soft. It's so soft, it's what we make baby powder out of. Okay, the second one is that beautiful rock that Ms. Ramirez showed you, and that is gypsum. It has a hardness of 2, and your fingernail has a hardness of 2.5, so you can actually scratch it with your fingernail. Look up there. You see where I scratched it? How about that? So my fingernail is harder than this beautiful crystal. The next one, we're going back to our lovely calcite right here, and we can scratch it with a piece of copper. So I'm going to scratch it right here, and you can see where it scratched it right there, because this has a hardness of 3 and this has a hardness of 3.5, so it's just a little bit harder. So there are 10. There are 10 different stages starting at talc and going all up to 10. 10 is the hardest mineral, and that is diamond. Nothing's in nature is harder than diamond. Diamond is the hardest. So those are a few ways we can test minerals to determine who they are or what they are.